Hi there, welcome to the Electronics Lab. In this video, we're going to look at resistors in series and try to determine what the equivalent resistance is when you have resistors in series. And basically what that means is when we have a circuit like this, what is the resistance that this voltage source sees? There's some number of resistors in series, R1, R2, maybe a whole bunch of resistors here represented by the dot, 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 all the way up to Rn. And what is that one resistance that this voltage source sees when you have all of these resistors? Well, what are some things that we know about this particular circuit? Well, we know that conventional current is going to come out of the positive side of the source and go through the entire circuit back to the negative side of the source. And let's call that current I. We also know that when current is going through each one of these resistors, it will go in on the positive side and out the negative side, or actually it'll create the positive and the negative side of each one of these resistors. We also know that the current through each one of the resistors is going to be equal, and also equal to the current from the source. So that I is equal to IR1 and IR2 and IRN. We also know that the sum of the voltages across each one of these resistors will add up to the voltage source. So we know that the voltage from the source is equal to the voltage across R1 plus the voltage across R2 plus all of the other voltages in between R2 and Rn, so whatever number those are, plus the voltage across Rn. What else do we know? Well, from Ohm's law, we know that V equals IR, and in this case, the voltage from the source is going to be equal to the current that's going through the circuit times whatever total resistance that voltage source sees. But we also know that VR1 is equal to that same current times resistor R1. The voltage across R2 will be, again, that same current times the resistor R2. And it's going to be the same for all of those resistors all the way up to resistor N. It's the current through it, which is the same for all of those resistors, times the resistance of N. So looking at these equations for the voltages across each one of the individual resistors and the total voltage, and this relationship between the total voltage and the sum of those resistors, we can substitute in each one of these equations to this equation. So we get I times that total resistance is equal to I times R1 plus I times R2 plus I times all of the resistances between R2 and Rn plus I times Rn. For each one of the terms in the equation, we have a common I. All of those I terms can be canceled out if we divide both sides of the equation by I. And what we end up with is RT, that total resistance, is equal to R1 plus R2 plus all of those other resistors all the way up to Rn. And that is the expression for calculating the total resistance when you have resistors in series with each other. And that's it. That's what I wanted to show you. That's the magic equation for this video. I appreciate that you tuned in. See you next time.